In this last lecture, we're going to take a look at the absorptive and postabsorptive states. So energy input is intermittent because we're not always stuffing our faces 24 hours a day. So we're going to divide things into the absorptive state, which is from when you just eat to about 3 to 4 hours after a meal. And during the absorptive state, there's lots of nutrients running around your blood. And then the post-absorptive state is in between meals. So it's been at least 3 to 4 hours after a meal until you next eat. And nutrients are starting to get low in your blood, and we're going to start breaking down the energy stores and mobilizing them. So let's start with the absorptive state. So this is from when you just eat a meal to about 3 to 4 hours afterwards. And there's lots of nutrients running around your blood. The primary energy source for most cells is going to be glucose because there's lots of it. And any nutrients that are not being used to make ATP, or maybe they're not being used to make other things in the cells, we're going to store that for later. And if you're going to be making these energy storage molecules that are larger molecules, this is going to be an anabolic state. So the absorptive state is primarily an anabolic state. So skeletal muscle and liver, remember, they're going to be storing glycogen. And then adipose is going to be storing triglycerides or fat. And this is a really nice flow chart from chapter 21. And if we start at the top, here's all the nutrients from your diet that you've eaten, and you've absorbed that into your blood. And because we've got plenty of nutrients, we've got lots of glucose running around, so most of the body's cells are going to be using glucose as an energy source and breaking that down and making ATP. And any extra glucose you have, you can store that as glycogen in the liver and skeletal muscle. And then we can also take any extra glucose that we don't store as glycogen and make that into triglycerides or fat. And we can also take extra fatty acids and turn that into triglycerides. And then amino acids, if we have extra of those, we can make those into protein. And then we can also take extra amino acids and unfortunately turn those into triglycerides to store for later as well. So here's how we store the extra energy in our body. So this is also from chapter 21, and it's just showing the glycogen stores in the body. So you can see that glycogen is going to be stored in skeletal muscle and the liver mostly. And triglycerides is going to be stored mainly in the adipose, the fat cells. And then most of the proteins are going to be stored in skeletal muscle. Remember that we're not going to touch those protein stores unless you're starving and you've already gone through your triglyceride and glycogen stores. The glycogen stores are actually very small in the body. There's only 500 grams. And the triglyceride stores are pretty much unlimited. So the fat cells can keep expanding. And so your body is going to store most of your extra energy as triglycerides. And the other reason we do that is because you're going to get twice as much energy out of a gram of fat as you are out of a gram of carbohydrates or out of a gram of protein. So it's a really good way for the body to save extra energy is to store it as fat. The other thing to point out on this table is looking at the brain. Notice that the brain does not store any extra energy. So the brain is reliant on a constant blood supply, bringing it nutrients. So if you cut off the blood supply to the brain and you're not delivering blood and glucose to it, it can no longer make ATP, and then those neurons start to die very quickly. So it just doesn't have any energy stores in the brain, and so that's why you get brain damage very quickly. Okay, let's move on to the post-absorptive state. So it's been at least 3 to 4 hours since your last meal and until you next eat. So nutrient levels in the blood are getting low. And the body starts to get worried because glucose levels are getting low in the blood. And the body needs to make sure that there's enough glucose for the brain to use, because the brain is very picky as far as what it uses to make ATP. So the brain, its favorite food to make ATP with is glucose. And if glucose is not available, it can also use ketones. Okay, and ketones will come from breaking down fats, so it can also use those. But otherwise, it won't use anything else to make ATP with. So we've got to spare the glucose for the brain. So what the body is going to do is it's going to say, all right, we've got to save the glucose for the brain. So all the other tissues in the body, hands off the glucose. We've got to save that for the brain. So all the other tissues in the body are going to switch, and they're going to start using fatty acids to make ATP instead. So during the post-absorptive state, we're going to spare glucose for the brain, and other tissues are going to switch and use fatty acids to make ATP with. And also during the post-absorptive state, because the nutrient levels are low in the blood, we're just going to start breaking down and mobilizing our energy stores. And so the post-absorptive state is going to be primarily a catabolic state. So we're going to be breaking our energy storage molecules down and releasing those into the bloodstream. And then the other thing we're also going to be doing during the post-absorptive state to help raise the glucose level is we're going to be making some new glucose from non-carbohydrate molecules. So remember, that's called gluconeogenesis. And do you remember which organ does gluconeogenesis? Remember, that's mostly the liver that does that. So the liver is always a pretty good guess if you're not sure with metabolism. So the liver will do gluconeogenesis. It'll make new glucose from things that aren't carbohydrates, and then release this newly made glucose into the blood, and then make that available for the brain to use, and then that'll raise the blood glucose and make sure it doesn't get too low, and then the brain will stay happy. All right, so this is a really nice flowchart from chapter 21 again, showing you all of these post-absorptive state reactions. And what I want you to notice is that the brain is going to be using glucose to make ATP, and could also use some ketones if it needed to. Okay, and ketones are going to be made by the liver from fatty acids from breaking down those triglycerides. And then all of the other cells in the body, they're going to stay away from using glucose, and they're going to be using mostly fatty acids to make their ATP. But if they needed to, they could use some ketones, and they could use some amino acids too if they needed to. Okay, and then just looking at our energy stores up here. So So you can see that we can break down the glycogen stores. So the liver can break down the glycogen and actually release the glucose into the blood. And the liver can also do gluconeogenesis as well and make new glucose. And then here we've got the muscle. The muscle's doing things like fermentation, making lactic acid. That lactic acid can go to the liver and do gluconeogenesis and make new glucose there for the brain. And then here's the adipose, the fat cells. We can break down the triglycerides and release some fatty acids for the other body cells to use that to make ATP. We can also take the glycerol. Liver can do some gluconeogenesis there and make new glucose for the brain. And then if you're starving, you can take the proteins from the skeletal muscle cells and start breaking down the proteins into the amino acids and release those. And then the body cells could use that to make ATP as well. Okay, so we do need to switch between the absorptive and post-absorptive states. And remember, there's very different reactions going on. Remember, the absorptive state is anabolic reactions, and the post-absorptive state, we've got catabolic reactions going on. So the endocrine system is going to be controlling metabolism and controlling that switch between the absorptive and post-absorptive state. And that makes sense because remember we said that the endocrine system and nervous system, they're the two systems that are in charge of the body and they're telling everybody what to do and they maintain homeostasis. So it's not surprising to find the endocrine system in control of metabolism. So there's two hormones that are used to control the switch. We've got insulin and glucagon. And both of these hormones are actually made by the pancreas. And insulin is going to be secreted during the absorptive state. So it'll be released right after you've eaten to about a couple hours afterward. And what insulin is going to do is it's going to lower your blood glucose. And it'll tell your cells, hey, there's lots of glucose out there, start taking that in and use that as an energy source, or start saving it for later and making some of these storage molecules. Glucagon is just the opposite. It's going to be released during the post-absorptive state. And it's going to raise the glucose levels. So, and we're going to talk about that later, how it does that, but it'll do things like, tell your liver, hey, start breaking down your glycogen stores and start doing gluconeogenesis and things like that. Okay, as far as who is using the most energy in the body, the nervous system is the biggest user of energy. It's going to use 40% of the basal metabolic rate. The basal metabolic rate is just the energy use when the body is at rest. And there's a lot going on in the neurons, so they do a lot of active transport, use a lot of ATP. And then the second biggest energy user in the body at rest is skeletal muscle. So they use about 20 to 30%. So I'm not going to ask you the percentages, but just kind of know like who the big energy users are in the body. So that's all you need to know there. Okay, last thing we're going to take a look at is just keeping straight all of these terms. So I want you to know definitions, and then also, are they happening during the absorptive or post-absorptive state, or both? So let's start with gluconeogenesis. So remember, this is you're making new glucose from things that aren't carbohydrates. And so this is the liver doing this. And remember, we're going to be doing this during the post-absorptive state. So that's when this would be happening. So we're going to put a PA, which stands for postabsorptive state. So when the glucose levels get low, the liver is going to look at that and say, hey, we need to make some new glucose to raise the glucose levels up and keep the brain happy. Okay, so gluconeogenesis happens during the postabsorptive state only. Okay, glycolysis. Remember, that's where you split the glucose in half. That's that first step of aerobic respiration. And remember that you're always doing aerobic respiration. You're always making ATP. So that's 24 hours a day, right? So you're doing that in both the absorptive and the postabsorptive state. So you're doing that all the time. Okay, and then we have glycogenesis. So remember, genesis means to form or produce, and glycogen. Okay, so we're forming glycogen. And when you would want to be making glycogen would be during the absorptive state. So remember, you just ate, you got a lot of glucose running around, and if you're not using it all, you want to store it for later. So you're going to make some glycogen. So, and remember, we're going to be storing the glycogen in the liver and the skeletal muscle. So that's where glycogenesis would occur. Okay, then we have glycogenolysis. So lysis, split, break apart. And so we're going to start breaking the glycogen down. And we would want to do that during the postabsorptive state, because nutrient levels are low, we haven't eaten for a while, and so we want to start breaking that glycogen down and then releasing that glucose into the blood so we can start using that. And so that would be the postabsorptive state. We would do that. Okay, lipogenesis. Remember, genesis is to form or produce, and we're going to be making some lipids or triglycerides, and we would be doing this during the absorptive state. So remember, that's you just ate, you got lots of nutrients, and you're like, well, we got too many, we're going to store them for later, so we'll make some triglycerides. Okay, lipolysis, that's where you're going to be breaking down the triglycerides, and that would happen during the postabsorptive state because it's been a while since you've eaten, nutrients are low, and so you're going to start breaking down those triglyceride stores and releasing that into the blood, because remember that your body cells are going to be wanting to switch over and use those fatty acids to make ATP because they can't use the glucose anymore because we got to spare that for the brain. Okay, and the last one, proteolysis, that's breaking down the protein into the amino acids, and that would happen during the postabsorptive state. So nutrients are low, and you would break the protein down into the amino acid and then release that so cells could use that as an energy source. And remember, we wouldn't break the proteins down in the skeletal muscle unless you were starving. So you'd have to go through your fat and glycogen stores first. Okay, so make sure you know what all these terms mean, and also know whether they occurred in the absorptive or postabsorptive state or both.